In the previous parts of the video, we saw how to ingest data from multiple sources, different data types like CSV, text file, and even how to ingest the data from a database. And we also saw about the exploratory data analysis, like how to do a single variate analysis, multiple variables analysis. Uh, Here in this video, we are going to see about building a predictive model. So we are still using the same data set. We are using the Melbourne housing price data set. So here we are going to predict the price of the property. So now let's see how to draw about in building the predictive model. So here, since we are predicting the price of the property, what we are going to do is, the first one is we are going to remove the properties whose pricing values are not available. So even if we are going to predict the pricing for these properties, there is no means to check or to validate the prediction. So what we are going to do is we are going to fetch only all the records where the price is not null. So let's just execute this command. So now what this does is this just removes all the records where the price is not available. So now having removed all the records where the price is missing, so the next aspect is converting the categorical data into numeric for the training purpose. So what we see here is there are about 21 attributes like the suburb, address, and types, which has string values which can't be directly used in the model. So what we are going to do is we are going to use a function that would convert the categorical data into the numeric data. So let's just use this and see how it is transforming. So if we print the top 5 attributes, what we see here is all the attributes which was a string is converted into numeric, and it's not been converted into a random number. So what we see is all these suburbs like Abbotsford is represented as 0. So in this case, all the properties whose type is housing are being replaced by again 0. So we can see that method S is replaced by 2, and so each of the unit values are now being represented by an unit integer. So by this way, what we are doing is we are converting all the strings into numeric values so that can be consumed by our model. So the next part is we are going to do the correlation. So here we are doing the correlation in order to understand which attributes are highly correlated to our target variable or the dependent variable, which is the pricing. So what we can see here is these are all the 21 attributes, and then we can see how they are correlated with each other. But here the most important one for us is to see the relationship of all these 20 attributes, right, excluding price, and how they are related to price. So what we see here is we see here the number of rooms in the property seems to be highly correlated to price, and the type of the property seems to be like negatively correlated to price. So this is the same attribute, hence it is 1. So what we are going to do is we are going to go through all these values and just filter out the attributes that are highly correlated. So it can be positively correlated or negatively correlated. We are going to consider both of them. So hence, so you can see the below attributes here. So these are all the attributes that have been filtered based on the correlation value. So we can see rooms is highly positively correlated, the type of the property is negatively correlated, and we can see distance is as well like negatively correlated. So maybe we can set a threshold as 0.15. So in this case, and anything like anything above 0.15 or anything below minus 0.15 can be considered for the further analysis. So now the next part is we have filtered the attributes that we think are most important for the prediction. And what we are going to do is we are going to check the correlation once again for just these attributes. So let me execute it. Okay, so now we have reused the correlation function, but only for the filtered attributes. So this is to ensure that we are not retaining any attributes that are highly correlated with each other. So here what we can see is the attribute rooms as well as the attribute bedroom 2 seems to be very highly correlated with each other, which is like almost close to 1. So what this means is that just we can stick to one of these attributes for the model, as both of them are anyway trying to say the same thing, and by using both of them we are going to add some additional noise to the model, so which is not going to be good. So what I'm doing is I'm going to remove the attribute bedroom 2 from the data set, and just going to pick the top 5 records to see how the attributes are. So now what we have done is we have removed the bedroom 2 attribute from the list. So we have price, which is the dependent variable, and we have 6 other attributes which are independent variable, and so we are going to build the model using these attributes. In the above data frame, we can still see that there are some attributes with missing values. For example, the year built is still missing. So what we are going to do is we are going to use a package called simple imputer. So what it would do is it would replace all the missing values with either the most frequent item or mean, or like we can follow any strategy. So here what we are going to do is we are using fit.transform. So here we are going to replace all the missing values with the mean. So let's just execute this script here. So now we have replaced all the missing values for the other attributes, like for rooms type, distance, bathroom, cars, and year built, with an mean value, and hence the data is now complete. There isn't anything that is missing. So the next step is dividing the data set into training and test data set. So what we are going to do is we are going to use the test size of 0.3, which is like 30% of the data set will be separated for validation purpose, and remaining 70% can be used for the training purpose. So here this would split the data set into training and validation or test data set. So next is the actual model building. So here what we are doing is we are going to use a simple linear regression model, and with the default parameters, and the second one, the model.fit. So this is where we are going to build the model based on the training data set. So we pass all the independent variables as well as the dependent variables. So based on the patterns that is available in the training data set, the model will hold the relationship between the dependent and the independent variables, so which then can be used for making the prediction. So now let's go ahead and build the model. Okay, so now let's predict it. The model has been built. So next step is what we are going to do is for the validation data set, so which is this one here. So we are going to use the model that we have just built based on the training data set to predict for the validation set. So let's execute this one. So now the predictions are stored in the predict_y data set. Let's see the plot to check the deviation between the actual prices as well as the one that is predicted above. So the actual prices are stored in val y, and predict_y holds the predicted price for the property. So by running this one, so we can see that there is a trend here. So this plot is between the actual price as well as the predicted price. So there are some deviation, like there are a lot of deviation because this is just a simple model. We haven't really used any advanced machine learning model here. So there are some deviation, but let's check out how much is the deviation. So here what we are doing is we are just converting that into a data frame, and we are naming the columns, and we are just bringing the actual as well as the predicted attributes side by side so that we can do the comparison. Okay, so this is the actual price of the property and this is the predicted price. So since this is in the exponential, it's not very clear. So what we will do is we will just use a function to convert them into integer. So it's still the same one. So what we are doing is we are just converting those two attributes into integer. So let's just rerun it. Okay, so now this is clear. So this clearly shows us what's the price of the property and what we have been predicted. So we can see there are some differences. It's of course because like we haven't done really any transformations, or we haven't really used any advanced machine learning algorithm. So we have all we have done is we have just used the simple linear regression with the default parameters, and we replaced all the missing values with just the mean of that letter, the attribute, and hence still we can see that we have been pretty close to the actual values. So by making some improvements in handling the missing values, or maybe by slightly using like advanced technique such as maybe an SVM or a random forest, I'm sure that the accuracy of this particular model will drastically improve. So that's it about the predictive model here. So in this series of videos so far, what we have done is we have covered reading data from multiple sources, and we have seen doing various exploratory data analysis, and about building a simple linear regression model. So in the description, I will be providing the link to the source code as well as a few of the links to materials that can be really useful if you are learning to do or learning to build a predictive model. So that's it for now. Thank you.